RMQ problem, or range minimum query. Today we will implement it in Haskell. So what is RMQ problem? So we have some array and also we have some range in this array or some subarray, and we need to find the minimum number on this range. So we will do the implementation which do the preprocessing in n log n time on this array, and after this we can very fast for a constant time query some do some queries on this array. And let's define type signature for our function. We will have RMQ function, and it takes some so we have the I think we have the array of integers, and we need to provide some starting position, as we will represent it as the integer of our interval, and some ending position. This is also the integer, and also of course we need to have some array. We will how can we represent our array? I think as we can start our initialization from a simple Haskell list. So I can use simple list here, and after this I need to provide the minimum itself for this interval. So for this interval we need to provide this minimum in this list. And let's go to implementation. We have RMQ function. They have left position of our subarray, right position of our subarray, and they have our list xs. And here we need to write our definition. So for preprocessing we will use parse table, and also we will use we can calculate all the subintervals, but we will only calculate the intervals of size power of 2. Okay. Okay, let's write this as a range size power of 2. So actually what we need to construct? We need to construct some matrix or function. Okay, I can write as f some matrix f which have 2 indices. The I is the position in our list, and the k, this is the number of elements which so this is the length of the interval which starts at this position I. Okay, and actually it's defined as a minimum of our if our A is our initial array. Okay, let's mark it as A as initial array, then we need to take the minimum from this range from I to 2 power k. Okay. So if we construct this matrix or we provide this function, we will have this information about these intervals. So this is a some sparse table. Actually we need from I to I plus 2 power k. So we have this interval, and we need this minimum here. So this is our plan. So this is our somehow plan. We need an init array, and after this we need to construct this function or a matrix with the pre-computed elements. Okay, and after this we want to know that we have solutions only to these intervals, some or the part of all possible intervals. But what if we need to calculate for every possible interval, and we need to somehow extract this information from here. So if I provide this function from which takes left and right, let's call it m function as a minimum from left to right, how we define it. So we can take this pre-computed function f for the position length and some interval k. Okay, this modified k. And problem is that we can't actually they can't find in this table this k, this k, modified k. In a common case we can't find it. If it is a multiple of 2, we can find it, but if it is not, we can't find it. But let's take here the lowest possible interval which we have from here. So I mean that here our k is our k. Okay, let's write it as a where k is logarithm of r minus l, and we take lowest bound, and this is our k, modified k. And also we can take the interval, the second interval. So our second interval is we start with the position r minus modified k plus 1. And we start here and go till r. And also we can take the pre-computed minimum in this range. And these two ranges will overlap, but because they have the minimum function to compute the whole interval, we can just take the minimum function from these two intervals. And this is the main idea which I want to implement here in this implementation. Oops, I need to fix here, not r. Here we have modified k. And actually we can write this thing in our definition. We need to use a minimum from two things. The first thing is our additional aux f function, which we need to some interval started with l and of length k. Okay, and second part is to take our function with these parameters. So actually this is two subintervals, possibly crossed subbit intervals, and we need to choose the minimum element from these two subintervals, and this will be our minimum query. After this, of course, we need to do the definitions of all these domains. I think we can start to define our key at first. I write this little helper function logarithm with base 2. So actually this is the floor of this logarithm of base 2. And we can define our additional key as log of base 2 of r minus l. Okay. So this is our maximum interval, which is a multiple of 2 in our range r minus l. Started with l. And I think I make a mistake here. Actually, here we have the power 2 in the power of k. Yes, and they need to fix it here. And the last thing they need to define here, and I think this is the hardest part, it's our f function. Okay, it takes some position in our initial array and some k, and return to us the minimum of the interval from from a to 2 power k, from I plus 2 power k. Okay, and we need to define this. Actually, I think I will define it as a preprocessing function. So let's call it prep. This means that it do some preprocessing, and we need to actually this function f is of course it is used use this preprocessing matrix, and this matrix we need to preprocess it first. And here actually I think we need some additional parameter to pass in this function, the preprocessed argument. But let's just start with preprocessing function, and then I will possibly modify this interface here. What they need to construct our matrix? Of course, they need a list, our initial list of ints, and what will give as a result. Because we want a constant time query, we can't use list here, because the list actually is a linked list, and access is a not constant time. So I think I need to use vector here, and IO vector of type int. And if I build this vector, I can, because vector is implemented as an array, and it has constant time access, so this means that I can use this vector for fast query. And I think we also need IO monad here, because I want to work inside IO context. I want to do some modifications. Okay. We have our list, and here we need to, at first we need to create our vector. And what's the length of it? So I think the length of the vector is actually the length of our list, and we need to multiply it by maximum k. How we define our mk? And this is the log with base 2 of the length L, or the length of our initial list. So we can extract our vector. Actually, here we need to add 1 because we start from 0. So our k start with 0. This is the case for it. Okay, now we need to think a little bit about how can the define this function in terms of itself. So if we look at this interval from I to k, we can take the minimum on the first half of this interval with a function f from I to k minus 1. So this will be the minimum of the first half of this interval. And how can we get the minimum of the second part? We can take our I and add to it 2 power power k minus 1. And so we take our f from this index and with k minus 1. This is the minimum of the second part of this interval. And we can take minimum here. So actually here I defined it as a recurrence in terms of itself. So this function is defined in terms of all of itself, and we can according to this formula construct the full matrix so we need to start from k0 and increasing it until our maximum k. And also we need to start from I from 1 until the length of the initial list. And for every k, we do this for every k. And how many actions we need to take? It takes length of the list multiple k, and k is log n, so it's take n log n actions to build this table using this recurrence function, recurrence equation. So now I want to add some model here. Control monad, I think. And what I want to do here, so I want to do some monadic actions for every pair of the indices or the k and y, and each action for each pair of the real list will modify it with some action which actually calculate their function in this point. Okay, so we use this for m. Let's look at its type signature. For m, okay, I need to import it here. Control monad for m. So we have some traversable, and this is our pairs for our sequence, pair sequence. And this is, and next thing is our monadic action. Let's call it act. And let's define at first our sequence of pairs. So actually this is a list of pairs, and we can define it as so we can start from 0 to our mk, maximum k, and we take some k. After this we need to go through all the i's, and this is we have i's from 0 to length of the list minus 1, I think. And they return the pair of our k and y. Okay. Now we can define our action. Actually, I think we need to provide the vector for our action at first. So we have this vector, and the second argument will be this is a, and this is actually this is a pair which consists of level k and index y. And here we need to define our monadic action. Actually, I think we have some cases here. The first case if our k is equal to 0, this means that we have the interval, we have the we have the element itself, so this is a 0 interval. And actually, in this case, our function is actually the minimum of the interval. Only one element is the element itself. So this means that we need to write our vector. So we write inside our vector v in the position e, I, and k. So here we need to define, actually we need to define index inside our vector for our I and k. And actually we do some flattening here of the two-dimensional matrix inside single dimensional vector. Okay, and what we write in? We write in actually the element itself. And here we have the problem because I need to access this element from the list. And this can be slow. This means that I need to modify this list. I need to transfer it to vector. And after this, I need to use this vector to extract my element. So I think this will be initial vector. So I will use some read function for my vector ev, and its index I with k0, like this. And otherwise, if our k is not 0, we also do writing inside our vector, but we do it using this recurrence. Actually, I need to do two reads here, vector reads, and take the minimum of them. So I take the minimum of the vector read v, and here I need to provide some index. Surely I need to provide these indices. And Also, I need to do secondary. Actually, this is this read. I need to modify this I here and provide key -1. Something like this. Of course, I need to define this initial vector. I need to construct it from my list L. So I will use from list vector from list and provide my initial list. And here I think I can use indexing like this. Also, I need to provide the indexing function, which takes I and k, and we take I multiplied by length of our initial list and add k. And here I think we need to return our vector v. I do a little bit modifications here, so I refactor this write function. Actually, the read returns to me the monadic action, so I need to extract value from it. So I extract p1 minimum value and p2. So this is, this is the parts of our interval. First part and the second half of the interval, and they just extract the minimum and write it to our vector. And also I define this start of the second half of the interval. Now let's try to start our cabal with built-in dependencies vector, because we need a vector. So I will start GHCI and with the vector module and try to load my file. And we see this error here. Mutable. Here I need to fix this thing. So let's fix these module prefixes. Here fix if undefined. Also, I need to do one fix here in this line. I forgot to insert the index parameter. So we construct this parameter via additional int function, and we need to provide the I and k for it. So it just map these two numbers into a linear range of integers for the indices. So they map 2D matrix into one-dimensional matrix. And after this, our model compiled. Well, this means that our preparation function, we can try to run it, but I think I need to look more carefully about on it, and maybe some logic errors in this indices. There are many index manipulations here, and of course we need to somehow test it. Oh, next fix, so I need to do is here. I think I did a mistake. I need K here and I here. So this is our two-dimensional to one-dimensional mapping. Actually, I think I need to remove this -1 here. This is the correct index. And after this bunch of fixes, if I run my preparation function for this list, the result, I have this matrix. So this row with 8 elements, we have 8 elements. The first row is represented our minimum function for the intervals with k equal to 0. So the elements, this is the elements itself, and you can see this exactly our initial list. Here we have next row which represent our intervals length 2, and if we take these intervals, at first 8 and 7 minimum 7, next is 7 6 minimum 6, 5 4 minimum 4 sorry 6 and 5 minimum 5, 6 and 7 minimum 7, 8 and 7 minimum 7, 5 and 4 minimum 4, 4 and 3 minimum 3, 3 and 2 minimum 2, 2 and 1 minimum 1, and for 1 our minimum is 1, and so on. The next is next row represent the minimum for k with k equal 2. This is subarrays of length 4, and that's why we have 5, because they take this subarray at first. At second they have this subarray, and here minimum 4, and so on. And of course the last row of our matrix is for k equal 3, and this is the sublist of the length 8, and for every element this will be 1, okay, because if they take from this position 8 elements, this is the 1 minimum, from this position this is the 1, and for every other position we have 1 as a minimum, so we have 1 here. Okay, now let's if we look at the type of this expression, they can see that we have this type IO with the empty tuple, but I think I want to return my v1. So I want to return our matrix which represent our I want to return my vector which represents our 2-dimensional matrix. Okay, now when they have this vector, this constructed vector, we can use it to do some queries here. Of Of course, after I do these modifications, I need to change, I think, a little bit type signature here. So I will remove this list because when I do the query, I don't need to provide this list. I will provide actually constructed prepared data. And this means that I want to use this type here with these constraints. Okay. So we provide the constructed vector matrix here, and we provide the left and right interval points, and we return our minimum on the range. Of course, because I here in IO, I think this means that I also return results in IO. We can fix this. We can remove this IO from here by, if I modify here a little bit, if I move from here to stmonad, but I don't want to do this because this will take some time. I will state inside my IO monad, and I just use this vector here. So we have our vector prepared vector, and actually what we need to do, we need to just use this vector to extract the information. And I need to little bit modify the implementation of this function. So because we return the IO monad, I can use the notation here, and I need to return this integer which I get from this min expression. And actually here I can redefine this index UI index like this, I think. And actually what they do, so at first I think I need to here we have wrapped inside IO vector. I need to extract my vector, unwrap it, and I will go to this vector. Okay. And now I need to read from this vector. So I think I need this index function here. But if I use this index function here, and also I need it here, I can extract it at the top level. Oh, I need to provide length here. Yes, I need to provide also length. Okay. Okay. I will give the length, and I will define new index here as the index with fixed length. Let's call it index. let's provide this length. And use length here. Something like this, I think. Here, of course, here this length. This length. And of course, I need to remove this cake here. Because they already defined here. Okay. Now I can use my vector to extract the information. So I provide them. I need to provide the index. So this is the left position here for our interval. So we need, of course, we need to construct this list, this index. So we have this index function for which we need to provide the length. I can get the length from the vector, and also I provide the position and the key. Okay, so this is the left position and the key, and this will be this part. So this minimum of the first part, first half of the whole interval, and the minimum of the second part is defined using these parameters. Okay, and they need to substitute the length here. Here I can change this to these new definitions. And let's use length here for my vector. Okay. So actually our function definition was the access into the vector, and we can remove it. Let's try to recompile. Of course, we need to use let here. And here we need to use a vector operator. We have I think we have of course we can use int here. I can remove all these type classes, constraints. Okay, and we're done. Now let's try to build our preparation. So we build the preparation prep, and we will take some array. Okay, and we can use this preparation in our RMQ. So let's check the type. Yes, this is your vector, and we can use it inside our RMQ function. And we need to fix the constraints of our interval on the left and right position. For example, if I want to take from 0 to 7. So this is the whole minimum. Oh, exception, index out of bounds. Maybe I need to use 1, 2. So I have some problems with the indexing. But if I run the 2 and 3, I got 5. Okay, 2 and 3, and looks like true. So if they look at this interval, they have 5. If I run 2 and 4, I have an error. Yes, obviously there is some error in this code. I think here I need to add 1. This was stupid error. I provide here the length of my vector. I don't know why I'm doing this, because my vector very big. It's much more bigger than the original array. So we have original array 8 elements and the vector 32 elements. Oh, how can I fix this? I think I simplest way to add here extra parameter, which will give me the original length of my array length, I think. And I can use it here. Something like this. Of course, not very nice interface, but we can use it to test. Okay, what we have? We have, if they provide the interval from 0 to 7, they have minimum 1, and it works fine. If I provide the interval from 0 to 6, I have minimum 2. Okay, I need to remove this extra debugging here. Oh, from 0 to 6 they have minimum 2, and from 0 to 5 they have minimum 3, from 0 to 4 they have minimum 4. And what if I provide, for example, from 4 to 5 minimum? And this is 3, this is correct. To 7. Yes, I think this thing work as expected. So it construct the preparation in logarithmic time, and here they have the construction preparation in logarithmic time and querying in the constant time. This is the implementation for static range minimum query. So this means that our initial array, they assume that it doesn't change during our querying. There also exists the dynamic range minimum query, so and segment tree is used there, so we can change our initial array. But in this video I want just to review this static implementation in Haskell, and I think it is done. So guys, thanks for watching. Push like, push subscribe button, and see you in the next video. Bye bye. And also guys, there is one gotcha in this program in terms of speed, and the tip is that this gotcha inside the request function. So if you find it, please let me know in the comments.